Hi, everyone. This is a solution to problem 8 on homework 5 for statics. And here we're given a beam, A, B, C, D, E, and a series of loads. And we're asked to convert this into a single force and moment that are acting at point D. This is another exciting equivalent systems problem where we're given kind of a mess as our inputs, but we can do a little math to simplify things if we want to do so. All right, so here is, we want to do equivalency. So these systems are going to be equal. So system 1 needs to have the same effect as system 2. That means the same net force, same net moment. And for system 2, this is what we're asked to solve: a force and a moment acting at point D. And it's kind of scanning this. All my forces are vertical, okay, and they're downward. So I'm going to put that force at D, vertical and down. Okay. If there were some X components, right? So if I had like this kind of force or things like that, I have to take that into account. But this one, everything's downward, so the resultant force has to also be downward. And it prescribes a location point D, and so I'm going to need a moment there. How much moment is going to be there? And I'm going to assume, I'm just going to make a random assumption. I'm going to call this M sub D, and I'm going to assume that it's counterclockwise. At this point, oh, yeah, and that's basically set up and ready to go. So we grab our equations of static equivalency. So the first one we need is that the summation of forces in the y direction in system 1 needs to match the summation of forces in the y direction in system 2. And I can choose to do upward positive or downward positive. This one, man, it could go either way, but just for the sake of being consistent in my teaching, I'll go ahead and do upward positive. Okay. So on the left side, I've got negative 10 kips. I've got minus 3 kips. I've got minus 6 kips. I've got minus 1 times 8. 1 kip per foot over 8 feet equals. And then over here, I assumed it was downward, so negative F sub R. And everything is negative. Everything is negative, which is why I was on the fence about just doing it this way. So 10 plus 3 plus 6 plus 8 equals F sub R. And adding all of that up is going to get me to F sub R is equal to 13, 27 kips. And we got a positive sign with this calculation, and that just confirms that our assumption downwards correct. Okay, so now we've got our F sub R is equal to 27 kips downward. And I'm ready to go to the next part of the problem, which is a moment summation. Okay, so for the next part, I'm going to do a moment summation. So I know that the summation of moments in system 1 has to match the summation of moments in system 2. And I get to pick an axis to sum moments about. And there's some arguments for a couple different locations to do this, but I'm going to pick D. I'm going to pick D. And the reason why I'm going to pick D is that in the event that I messed up this calculation, that error will not carry over to this because that resultant force is coincident with D. So it's a way of minimizing errors I may have. And I'll use a counterclockwise positive for this calculation. All right, let's do it. So subsystem 1 on the left side of the equation, first term, 10 kip. Distance to D, 3 plus 2 plus 1 equals 6 feet. Direction or sign positive. Okay, that's positive for counterclockwise. Next term, I have 3 kips. Distance from D, 3 feet, sign positive. Next term, applied moment, 9 kip feet. 9 kips times feet, and that one is clockwise negative. Next term, 6 kips at a distance of 1 foot. That one is thumbs up, positive counterclockwise. Last term, and I'm kind of going to do an intermediate step in my head, right? I don't know if you're quite ready to do that or not, but I'm going to convert this 1 kip per foot times 8 feet into 8 kips. And I'm going to measure that over from here to here as 4 foot. And once I've kind of made that equivalent system, I'm no longer paying attention to that line. Okay, so just kind of convert it over to a concentrated force. And let's add that term to our equation. 8 kips times 4 feet. And that one is going to be negative. All right, let's just double check this because there's so many ways to mess this up. How many terms? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks good. Does every term have the right units? Force times distance. 10 times 6, 3 times 3, 9. 6 times 1, 8 times 4. Okay, and spot check signs. So I should get positive, positive, negative, positive, negative. So I do a little, and not only when I'm teaching, right? If I'm just solving this myself, I feel like it's easier just to not make the error in the first place. So to double check my work instead of having a mess to clean up later. Okay, the right side of this, man, it's a lot cleaner, right? So I just need the summation of moments about D in subsystem 2. This force is coincident, so it's not going to enter my moment formulation. So all I need is this couple moment. That's what I'm solving for. So we'll toss M sub D here. And I drew it counterclockwise, which per my sign convention is considered. All right, I'm going to go to calculator for this thing. So I've got 60 is my first term, plus 9 is my second term, minus 9 my third term, plus 6 minus 32 equals. And I get a moment at D equal to 34. 34.0 kips times feet. And we got a positive sign, which validated our assumption. So we can just kind of add that into our final answer just like that.